Hi everyone, we're ready for part 3 of our introduction to limits, and this one will be on piecewise functions. We should start by talking about what a piecewise function is. And basically, a piecewise function is just a function that has multiple parts. For example, we could have f of x is 3x when x is greater than 0, and then f of x is 2x if x is less than or equal to 0. Piecewise functions often occur in business, so I thought we should look at some examples of what that looks like. I found a place where you could order a hoodie. And notice that the price is based on the quantity that you order. So if you order 36 or more, you're paying $24.19. If you get to 72, then the price drops down to $22.60. If you order 144 or more, the price is $20.35. 250 or more, we pay $19.12. And then if you order more than 500, the price would be $17.97 a piece. So what we see here is that the price is changing with quantity. So the more you buy, the less it's costing. So let's just do a couple. Let's find some prices to make sure we understand how this works. So let's start with 50. 50 is in the 36 plus. So this means that we are going to pay $24.19 times 50, which is $1,209.50. If we change that to 70, well, 70, we're still paying the $24.19 per hoodie. So this is $1,693.30. At 72, we get a new price. It was $22.60 times 72. And the price is $1,627.20. And look what just happened. We could buy 72 hoodies for less than we can buy 70 hoodies. So it makes sense to order those couple more to get a significant savings in our order. All right, so let's see if that happens again. I picked 140. So 140 is still in the 72 plus, so we're paying $22.60 a piece. And we're ordering 140. That comes out to $3,164. But let's order 145. So 145 falls into the 20.35 a piece and times 145. And that gives us $2,950.75. So quite a big savings there. Let's look at some more piecewise functions, but written out algebraically. So this function says f of x is equal to 8x if x is less than or equal to 18. It's 12x if 18 is less than x, but x is less than 65. And then it's 9x if x is greater than or equal to 65. So we're starting with 30. What you want to do is look at where is 30. So you're starting with the x. So I look, is it less than 18? No. Is it between 18 and 65? Yeah. So because the 30 is between 18 and 65, we know we're going to multiply 12 times 30, which gives us 360. Then for 6. 6 is less than 18, so I want to use the first part. So this is 8 times 6, which is 48. 70. When I look at 70, 70 is over 65, so we're going to do 9 times 70, which is 630. And then 18. See how 18 is twice? I can see it at the first line. I can see it in the second line. What you want to watch for is where does it say equal? And it says less than or equal to 18 in the first line, which says we're going to do 8 times 18. We get 144. When you're doing this, one input, one output, you start by saying where is x? And then that's where you plug it into that particular line. So I should only have one answer for each of these. Now we're ready to talk about limits of piecewise function. Remember that the limit as x goes to c only exists if the limit as x goes to c from the positive side of f of x is equal to the limit as x goes to c of the negative side of f of x. We want to be careful with the values of c where the function changes its definitions. We want to make sure the positive side and the negative side are the same in order for there to be a limit at c. So let's go back to that first example we had of f of x is 3x when x is greater than 0 and 2x if x is less than or equal to 0. And let's look at a few limits. So we're going to start with 0 from the positive side. 0 from the positive side is numbers greater than 0 but close to 0. So numbers bigger than 0 are in this first line. So even though 0 isn't included there, that's okay. Numbers close to it are. And to get 0 from the positive side, we're just going to do 3 times 0. Is 0. From the negative side, we go to the less than 0, and we do 2 times 0, which is 0. When I look at the positive side, I look at the negative side. They're the same. They're both 0, so that says the limit overall is 0. Other numbers where there's not a split in the function, we just plug the number in. So the limit when x goes to 4, I look at 4 is greater than 0. So I do 3 times 4 is 12. Negative 5 is less than 0, which says you do 2 times negative 5, which is negative 10. So numbers that are not on this boundary where the function is changing, I plug them in like normal. But the numbers where the function does have different definitions, we have to look at the right side and the left side to figure out the limit overall. So let's do another one. Here I have f of x is equal to x plus 4 if x is greater than 3, and it's x squared plus 1 if x is less than or equal to 3. And of course, the number I want to know about is 3. So I first have the limit as x goes to 3 from the positive side of f of x. So positive side means bigger than 3. Bigger than 3 says do x plus 4. So 3 plus 4 is 7. For the negative side is the less than or equal to 3. That says I do 3 squared plus 1. 9 plus 1 is 10. So the positive side was 7. The negative side was 10. 7 and 10 are not equal. So the limit at 3 does not exist. They don't touch. They're not the same value. If I look at the limit as x goes to 1 of f of x, well, 1 is less than 3, so I'm using the second line. 1 squared plus 1 is 2. And then limit when x goes to 6, 6 is bigger than 3, so I'm using the first line. 6 plus 4 is 10. Here's a little bit bigger one. I put 3 lines on it, so I have 5x. If x is greater than or equal to 0 but less than 4, it's 3x plus 8 if x is greater than or equal to 4 but less than 10. And then 2x plus 5 if x is greater than or equal to 10. And I'm going to start with the boundary point of 4. So the limit is x goes to 4 from the positive side. So take a look at it. Where do you think that is? Where do you think 4 from the positive side is? First line, second line, third line. Take a minute to look at it because I want you to see bigger than 4 is the second line. So the second line says I do 3 times 4 plus 8. 3 times 4 is 12. 12 and 8 is 20. 4 from the negative side, that says a number less than 4. So this is the first line, and it says do 5 times 4, which is also 20. That's good news. 20 on the right, 20 on the left, says my limit is 20 altogether. Well, let's look at 10. So again, start by looking at 10 from the positive side and decide which line are you using. First line, second line, third line. Right? Hopefully you see it's the third line, bigger than 10. So we're going to do 2 times 10 plus 5. So 2 times 10, 20 plus 5 is 25. Then 10 from the negative side says I want to be close to 10, but smaller than 10. So smaller than 10, but still close to 10 is the second line. So now I do 3 times 10 plus 8. 3 times 10, 30, plus 8 is 38. Overall, then, if I look at the limit when x goes to 10, I need to say does not exist. I have 25, I have 38. Those are not the same number. It's not equal, so I don't have a limit there. Let's look at another example of piecewise functions in the real world. So I went to the North Las Vegas water rates, and I took this directly from their website. It says residential water rates consist of a daily water service charge based on the size of your meter and your monthly water consumption. Consumption fees are calculated in a 4-tier billing system. As more water is used, the rate per 1,000 gallons increases. The below table shows rates for a 3/4 inch single-family residential meter, the most common service in North Las Vegas. This is the rate per thousands of gallons. So every 1,000 that you use, you pay $2.14 for the first 6,000. For the next 9,000, you pay $2.77. For the next 9,000 after that, $3.61 per thousand, and then the last tier, $4.66 per thousand. What this is saying is that water is important, right? And it's a resource that we care about. So how do they get people to reduce how much they use? They charge you more. So let's just try this. We won't do a limit. We'll just do plug the number in just to get used to it, and then I'll do a limit in the next one. So I said, how much would a customer be charged for using 20,000 gallons of water in a 30-day billing cycle? So 2 things are going on. Every day that you have the daily water, you get charged 38 cents. So we know this 30-day billing cycle, that's the easy part, 30 times 0.38. The second part is 20,000. So 20,000, when I look at it, we have to break it up. For the first 6,000, there was this price of $2.14. And then the next 9,000, it was $2.77. Well, if you look, 6 plus 9 is 15. And we said we're using 20,000 gallons. So that means we need 5 more. So here's 5 more, and the rate for that is 361. 6 times 214 plus 9 times 277 plus 5 times 3.61. So this says the water bill would be $67.22. So let's try writing a piecewise function, and then we'll look at the limit. So this one I totally made up. I was trying to simplify it a little because this is still new. So I said an audio bookstore charges customers $5 per book download for customers downloading at most 10 books a month. After 10 books have been downloaded in a month, additional books can be downloaded for no additional cost. Construct a piecewise function, c of x, for downloading x books in a month. Then we'll find the limit as x goes to 10, the limit when x goes to 6, and the limit when x goes to 20. So let's start. Start with c of x. So this is our cost, and there are 2 pieces. At first, we're being charged $5 per book, so that's 5 times x, but that's up to 10, so that says x is less than or equal to 10. If you want to be really precise and say 0 is less than or equal to x is less than or equal to 10, you can, because this is an application problem. We couldn't have negative books, so it might be nice to put that 0 boundary in there. Then anything over 10, there's no additional cost. So notice that 5 times 10 is 50 for anything bigger than 10. So the first question says, let's find the limit when x goes to 10 of c of x. Well, 10 is this boundary number. So I really need to know the limit as x goes to 10 from the positive side of c of x. I also need to know the limit as x goes to 10 from the negative side of c of x. Positive side is this greater than 10, which says it's 50. Smaller than 10, 10 from the negative side, uses 5 times 10, which is also 50. So I can see I got the same number both times, so my limit as x goes to 10 is 50. The limit as x goes to 6 of c of x, well, 6 is between 0 and 10, so that would be 5 times 6, which is 30. And then finally, when x goes to 20, 20 is bigger than 10, so we have this $50. So that finishes up our look at limits. Next, we'll start looking at continuity as we head towards the derivative.